All right, let's solve this triangle. So that they tell us that angle A is 38.7, side A is 29, and side B is 35. So when you have a situation like this, this is called the ambiguous case because you have angle, side, side, or side, side, angle. And whenever I do these problems, what I always prefer to do is draw them consistently always the same way, and it'll just make it so much easier to do these problems. So let's use green for that side and writing that angle. So first of all, side, what I would do is I would start by drawing a horizontal line and draw that angle and try to make it pretty close to 40 degrees. So here's maybe 33 degrees, or 30 degrees rather, like a third of a 90 degree angle. So it's a little bit more than that, so maybe like that. Okay, and then so I'm going to write in 38.7 degrees. So there's my angle A. So side A would be across from it, right? And side A, it says, is 29.0. So 29.0, let's just draw it right there. The reality is we don't know where that side is going to be, because what's going to happen is this line down on the bottom it should be a dotted line, because you don't know how long that line is yet. You know this line over here, we'll call that B. You know that B here equals 35. And you know A over on the right, because it's across from angle A, is 29. But see, the problem is that side right there, that green side, could very easily also have gone here instead. Do you understand why?
Yeah.
Can you see it visually? If that side is 35 on the left, I'm going to turn that into a red line there so you can see it. If that red line is 35 and A is a little bit smaller than that, but not a lot smaller than that, then you really might have two possible triangles that you can draw.
Okay.
Make sense?
Yeah.
And so your calculator, when you use the law of sines, is going to give you this angle right here. That's going to be your angle B in the calculator. We'll call that B sub 1, because your calculator only gives you an answer between negative 90 and positive 90 degrees, right? But in reality, this angle is also a possibility over here, because 29 would still be this side length. So you could have actually two different triangles that could be built from the same three given pieces of information. And so that's called the ambiguous case. So let's just do this one right here. So remember the law of sines. It says the sine of 38.7 degrees over 29. So the sine of that divided by that is equal to the sine of the sine of angle B, which we don't know yet. Right? I'm doing the angle B. I should have done that in red. The sine of angle B divided by the side length, which is 35. Now when you solve this equation, you get B equals 49 degrees if you round it to the nearest tens. Actually, it rounds to 49.0. So you get your B equals 49. So this number right here, that number is actually 49 degrees. But remember, you could actually have had a side over, or an angle over here as well. Let me make this blue. So this line right here is the same line, and that angle, this angle right here, that blue angle, what's it going to be?
131.
Can you tell what it's going to be? Well, this angle is going to be 49 also, because these are the same side lengths, right?
Yeah.
So therefore, this blue angle is going to be the the supplement of 49, which is 131 degrees. That make sense?
Yeah.
So B sub 2 is 131 degrees. B sub 1, it's the ambiguous case. There's two answers for it. B sub 1 and B sub 2.
Oh.
And now you could also find this side length on the bottom here. I'm going to highlight it. That's one of them. that would be your C sub 1, right? And you're going to have so you're actually going to have all this different information. So angle C, you either have angle C sub 1, this is angle C sub 1, which is going to be, if you use 180 minus those two numbers in the angle A and angle B sub 1, you get what?
92.3.
92.3?
Yeah.
Is that right? That seems like it shouldn't be a point, because neither... Oh, yeah, it is. Yeah, it is. 38.7. Okay. And C sub 2, same deal. Add that and 38.7 and then subtract those from 180, and you'll get
10.3.
10.3. And then also notice that you're going to have a side C sub 1 and a side C sub 2 that are going to be different. Side C sub 1, side C sub 2 is going to be what I just shaded in yellow there.
Yeah.
And side C sub 1 is going to be that whole thing right there.
Mm-hmm.
Make sense?
Yeah.
So you can find those using the law of sines again. All right? So remember that you're using this entire side for C sub 1, but you're only using this little part of it for C sub 2. But you're just using the law of sines with these different side lengths that you were given. That's all you have to do. I'll leave that for you to finish.